So this is showing the total solar radiation, and radiation also seeming a little bit lower in a couple of months, but not on for all the months. And then this is the photosynthetically active radiation, also reduced in the shell pasture system compared to the open pasture system for most of the months. This is again the 3-year data from 2005 to 2008. And then wind speed reduced, much reduced. We have already talked about the windbreaks as one of the agroforestry system, and this data showing initial pasture system because of the tree that is blocking wind, and it is much reduced in the shell pasture system compared to the open pasture system in most of the months. And then and then soil water content also higher in the shell pasture system than compared to the open pasture system. When we are talking about drought and water scarcity and all that, maybe planting trees into the production system would be helpful to conserve water more than not planting trees. And this is showing the evapotranspiration. So that is another way of losing water from the system. So in here, this data showing evapotranspiration was reduced in the shell pasture system compared to the open pasture system in all months. So another study we conducted in recently in Tuskegee University using the shell pasture and open pasture system over here. So these were the site about less than a mile. This is the open pasture site, that is the shell pasture site. We collected data, and here are our study team over here. So we measured greenhouse gases, carbon dioxide, methane, and nitrous oxide, both concentration and flow rate, May to August 2025. Every 2 weeks we collected the data, and then using 5 spot per acre plot in shell pasture, because we had a 1 acre plot each, and 3 spot per 0.5 acre plot in the open pasture, because we have the half acre plot there. So 6 minutes every spot, going and taking for 6 minutes 3 replication. Okay, so within 6 minutes there will be 3 observations every 2 minutes, and the data were collected between 8 a.m. and 12 p.m. Using the LICOR 7810 leaf for the carbon dioxide and methane, and nitrous oxide was LICOR 7820. So there are 2 analyzers over here. This is the collection chamber, and it was installed over a collar that we can see over there. And then we also collected the moisture and the soil temperature. This is the soil temperature sensor, moisture sensor, collected at the same time. Soil temperature 11.5 centimeter depth from the surface, moisture 3.5 centimeter depth from the surface. So let's look at data analyzed for correlation among all those major variables. And also we did the generalized linear model for the overall the data collected. And over here you can see all the model there. So we basically found lots of correlation among the major variables. We can see the methane concentration and flow, carbon dioxide flow, and the methane flow. Basically, and then we can also see the temperature, and then water content, and nitrous oxide, and then water content. So another is we can see the differences in the open pasture versus shell pasture. All the values like methane flux rate lowered in the basically this is more going into the system than the emission. So higher in open, more going into silvopasture over there. What is going? Okay, so methane concentration higher in open, carbon dioxide flush rate higher in open pasture, carbon dioxide concentration higher in open pasture. We didn't find the nitrogen flux, nitrous oxide flux rate between the system, and nitrogen oxide concentration higher in open pasture, and then soil water content higher in silvopasture, and then soil temperature higher in open pasture. So those are the overall results found. It is just the graph I would like to show you. The methane flux rate was just, the system was serving as the sink rather than the source for the, no it doesn't. Okay. So you can see more going into the system in the silvopasture as compared to the open pasture, but both systems serving as the sink rather than the